And the last thing I wanted to do is discuss a topic that I've worked with my Algebra 2 students. This topic is called evaluating or finding domains of functions. Finding a domain. All right, so let's take a look. Let us take a look. All right, so finding the domains. All right, so here we go. So let's say you have f of x. So you have f of x is equal to 1 over x minus 8. Domain, finding the domain means acknowledging all of the x values that can legally go into this function without it producing something undefined. All right? So the thing that I'd like you to be able to know about a fraction is anything is fair game for a fraction. You can have anything in the numerator and anything in the denominator except for 0 you cannot have in the denominator. All right, so the domain, some people who really don't understand domains, they might say if domain is to acknowledge every x value that can be substituted here and get some type of legal response or legal answer, they might say, well, x can be 0, x can be 1, you can put a 2 there. If this denominator can be anything, you know, x can be 9. But see, there's an easier way to acknowledge all of the answers rather than list them all down. And the way to acknowledge all of the answers would be to say that the domain is every real number. That's what that means. It's so much easier to say every number instead of listing all of them. So the way a textbook would write the answer to this is it would not list all of the answers. That would take too much time. So what they'll say is all real numbers except, you can put in any number in the world except for x is equal to 8. That's the way a textbook would list all the values of x you can put there. There are many more x values that can go in here as opposed to x values that cannot. So that's why we just acknowledge all x values can go in there and then just put some type of restriction on it except for 8, which would give you 0 in the denominator. Let's do another one. How about, let's say you have f of x is equal to 3x minus 4 over 2x minus 1. All right, 2x minus 1. So what's the domain here? Again, it's a fraction. Anything is fair game for the numerator. Anything in the world. A numerator can be 0, a numerator can be negative, a numerator can be positive. So don't even focus on the numerator because that can be anything. Your focus when you're working with fractions should be this denominator. And again, the denominator cannot be 0. The denominator can be anything in the world. The denominator can be anything in the world except for 0. So the domain here, rather than say that x can be 0 and x can be 1 and x can be 10, x can be 30, don't do that. You're wasting time. This list on this side is infinite. It would be so much easier for you just to say that x can be anything. The domain is all real numbers except x is equal to 1/2. X cannot be equal to 1/2 because 2 times 1/2 is 1, and that 1 minus 1 would give you 0 on the bottom, which you cannot have. All right? So sometimes domains cause people challenges. Let's try to do a couple more. Let's do a quick one. F of x, let's do a quick one. F of x is equal to x squared plus 3x. I'd like you to be able to see that you can square 0, you can square negative, you can multiply 3 times 0, you can multiply 3 times a negative or positive. There are no restrictions on what you can put in for x there. So for that reason, the domain here is any number in the world, all real numbers. You can put any number in the world in for x there. All right. So let's keep going. Let's look at another one. Let's say we have f of x is equal to a radical x minus 4. Now this is different. With a radical, you can never have a negative under a radical. The lowest number you can have under a radical is 0. I'm going to say that 3 times to get it rooted in you. The lowest number you can have in a radical is 0. The lowest number you can have in a radical is 0. I think that's 3 times I said that. The lowest number under a radical you can have is 0. That's the 4th time I've said that. So I'm trying to get that rooted in you. So that said, x can, it's all real numbers. The domain is all real numbers. Let's just show all the work. Sorry about that. I'm rushing a little bit because I only have a couple minutes left in the show. The domain here is all real numbers where x can be equal to 4 because the lowest number under the radical can be 0. So if you put a 4 there, you get 0 and it's legal. But then you can also have numbers greater than 4, like 5. I know we only have 1 minute left, 5 or 6 or 7. All right? So let's just do one more. We only have time for one more. So the domain is all real numbers. Okay, we'll focus on, I don't want to confuse you. This is the domain of that. All right, so let's do one more. Let's say we have f of x. Let's say we have f of x is equal to radical x plus 3. The lowest number you can have under radical is 0. So the domain here is all real numbers where x is equal to negative 3, because if you put a negative 3 there, you get 0. You put a negative 3 there, you get 0, but also greater than negative 3. All right? So that's all we have time for. God bless you. Hey, check me out on my YouTube channel, Dominate Math. I'm going to post this show and every show that I do, and you can, if we've gone too fast, you want to maybe review or study a little bit, you can check DominateMath.com. DominateMath.com and my YouTube channel, Dominate Math. God bless you. Have a good evening, and thank you very much for watching.